So in this video, we're going to go through two additional examples about how to solve logarithmic equations. Let's just remember that when we have a log and we have some base, that the value behind it, this value must be greater than 0, as a quick reminder. All right, first thing, I can see that this equation is an expanded form, so I want to condense it. Remember, ln is natural log, which is equivalent to log base e. When I condense it, I'm going to have the natural log of x squared plus 1. Addition, when we condense it, turns into multiplication, times x minus 2 equals the ln of 6x minus 8. When you have the same log base on the left and the right, and there's no additional numbers, there's not a number in front, there's not like a plus 5 in back, we are able to cancel out the log bases on the left and right and simply now solve for the variable x. So I'm going to start by foiling. I'm going to multiply the fronts, the outsides, the inside, and the last. And I'm going to move everything to the left-hand side and combine like terms. Nothing remains on the right-hand side, and on the left-hand side, I have x cubed minus 2x squared minus 5x plus 6. Now I'm glancing on the left-hand side because I recognize that sometimes when we have four terms like this, we are able to solve by using the grouping method, but I don't recognize any pattern. So now I have to go back and think, like, how do I solve a polynomial equation that looks like this? And so we're going to rely on the fundamental theorem of algebra. So I'm thinking of what are the factors of 6? Factors of 6 would be 1, 2, 3, and 6. Factors of leading coefficient would be 1. So I'm going to start by testing 1 and -1, 2 and -2, 3, -3, 6, -6. The nice thing is there's no fractions to worry about. There will be 3 solutions that says. Let's get started. So I'm going to start by testing 1, -2, -5, and 6. And as a reminder, where am I getting these values? These are the coefficients written in standard form. So I'm testing 1. I dropped on the 1, and I'm going to multiply and add down. Multiply and add down. Multiply and add down. And it worked. Wonderful. I know one of the solutions is x equals 1. We're going to come back when we actually come up with a definitive answer on what are the solutions, and we're going to look back at what is the domain of this to make sure that it fits into the domain, which means what can I plug in that produces an output or an answer. Now, when there's 3 items left, we're going to write this as an equation, a trinomial. So no x's, 1x, and 2x's. And then we can solve this quadratic equation either using the factoring method if possible. We can always use quadratic formula. So I think I can factor here. What multiplies equal -6 and combines to equal -1? That would be -3 and +2. So x minus 3 and x plus 2. I would set each one of those quantities called factors equal to 0, and I would solve. So one answer is x equals 3, the other answer is x equals -2. X equals 3 and x equals -2. Now let's take these answers. So right now, my preliminary answers would be 1, 3, and -2. The order we're writing them in doesn't matter. But now we got to go back and we got to remember about the domain. So let's go back up to this original part. I'm going to grab a blank piece of paper. And I'm going to press pause, and to each one of these quantities, I want you to remember that this quantity and this quantity and this quantity must be greater than 0. Go ahead and please solve. initially solved here, I took each one of these and I solved. So think of this as setting equal to 0 first. Setting equal to 0 first. One of them, excuse me, one of them produced an answer that had i's. It was a complex answer. I know that on my number line. I can't graph complex solutions. And then I have x is greater than 2, and I also have x is going to be greater than 1 1/3, or 8 6, also equivalent to 4/3. So it has to be true for all. So whatever I choose has to be true for both of these situations. So let's go back and let's look at our answers again. We believe one answer was 1, one answer was 3, and one answer was -2. This is what we're thinking. So if I choose 1, I want to know, is 1 in the area that's shaded? Yes or no? It's not. It can't be 1. Is 3 in the area that is shaded for both? Yes. Okay? It meets the criteria. Is -2 in the region? No. So based on the criteria of the domain, of the 3 solutions I was able to achieve, only one of them meets the criteria for the domain. So the only correct answer here is going to be x equals 3. What does this mean? If I came back up here and I plugged in 3 and I plugged in 3 and I did the math on the left, I plugged in 3 and I did the math on the right, the two sides would equal one another. Hands raised when you see which one works and which one doesn't. Just hands raised. Okay? 2. Okay, so how can we decide what works and what doesn't work? Well, if we look up here, let's just start with this original. Ready? 10. 10 plus 6 is 16. Okay, that didn't break any rules. The value behind here is greater than 0. Awesome. Good. Can you take the square root of 16? Yeah, you can take the square root of all's good. 10 minus 6 is 4. Again, if the value is greater. I like the value 10. It meets the criteria. Let's try 3. 3 plus 9. Oh, excuse me. 3 plus 6 is 9. Yes, you can take the square root of 9. We're good. We didn't break any math rules. But 3 minus 6 is -3. And that breaks our rules about domain. We can't be greater than 0. We can't be less than 0. So we call that an extraneous solution. So we're going to cross this out. We only have one answer here, and that is +10.